Welcome back. This is Dr. G again. This is the last video on version B of our first midterm exam. In this video, we're going to do a couple of word problems. I just want to remind you what the instructions for these word problems said. You're supposed to use algebra, meaning use variables and equations, because that's what we're assessing. We're assessing one of the student learning outcomes in this course, which is using algebraic methods to solve real-world problems. So guess and check is not going to get you full credit. All right? So in this video, we're going to do the last two problems, number 14 and number 15. So let's look at number 14. It says Melody invested $6,500 into two accounts. One account paid 4% interest and the other paid 6.5% interest. Turned out she earned 5% interest on the total investment. The question is, how much money did she put in each account? So the word problems, you might have to read them a couple times to kind of really understand what's going on. Then the next step is to write down a variable or variables and what they represent. Then set up an equation or a system of equations, solve that, then answer the question. So in this problem, Melody has $6,500 to invest, and she put it in two accounts. Now, she did not put $6,500 into each account, right? How do we know that? Because the question is saying, how much did she put in each account? Why would they ask us that if she actually put $6,500 in each account? So clearly she put different amounts into different accounts, right? So one account paid her 4% interest on that amount that she deposited. The other account, she got 6.5% interest on that other amount. And then when she added the interest together, she figured out that, oh, look, I got about 5% interest on my total $6,500 that I invested, okay? So that's kind of a complicated picture, but we're going to kind of break it down, define some variables, and write down some equations describing the situation. So to figure out what the variable or variables are going to represent, we look at the question that's asked. The question is, how much money did she put in each account? So that means we've got two unknowns. So I'm going to start with X for one of the accounts, one of the amounts of money. So X will be the amount deposited into the account with 4% interest. And then I'm going to use a different variable, Y, for the amount that she deposited into the other account, the account with 6.5% interest. So now that I see I've got two variables, I'm going to have two equations. I'll have a system. So my two equations, what are they going to represent? So I've got amounts invested and I've got interest earned. So I'm going to split those things up and write an equation for each of those things. In other words, I'm going to write an equation talking about the total amount of money invested. And then I'm going to write a different equation talking about the total interest earned on that money. So the total amount invested, it says that she had $6,500 to split into two accounts. So we know that the two deposits have to add up to $6,500. So X plus Y has to be $6,500, right? Now, what about the interest earned? So it says that she got a total 5% interest on the total amount, but she got some of that from the first account and some of that from the second account. So let's find expressions for the interest from the first account and the interest from the second account. So in the first account, she got 4% interest, so that means 4% of the amount she deposited, or 0.04 times X. The second account, she got 6.5% of what she deposited. So that's going to be 0.065 times Y, because she deposited Y dollars into that second account. And then in the end, those two things add up to be the total interest she got on the original the whole $6,500, and it says that she got 5% on that $6,500. So those two individual interest earnings have to add up together to be 5% of 6,500. So we've got two equations. So now there's two methods. There's elimination and there's substitution. This one, it looks like substitution will work nicely, and that's because in the first equation, both of those variables have a 1 in front of them. So it's really easy to solve for one variable in terms of everything else and not have any fractions. So I'm going to do that. I'm going to solve for y in terms of x, just by subtracting x from both sides. You could do it by solving for x in terms of everything else if you want. It doesn't matter. Then I'm going to plug that into the second equation. But before I do that, notice the second equation has a bunch of decimals in it. I don't know about you, but I don't like them. I make a lot of mistakes when I have decimals. Even when I'm using a calculator, I punch things in wrong. And the same thing with fractions. I don't like them. I get rid of them. So to get rid of the decimals, notice I have one of the decimals has 3 decimal places, 0.065. So I've got to multiply, to get rid of that decimal, I've got to multiply by something with 3 zeros. So I got to multiply by 1,000. So let me multiply both sides of the equation by 1,000 to get rid of all of my decimals. And like I said, I'm going to also plug in for y. I'm going to plug in 6,500 minus x. I'm going to plug that in for y. So when I multiply both sides by 1,000, I just move my decimal places 3 places to the right. So 0.04 becomes 40. 0.065 becomes 65. 0.05 becomes 50. So I'm going to write down my new equation. I'm going to have 40x plus 65 times, and instead of y, I'm using 6,500 minus x, equals, and then I'm going to have 50 times 6,500, and so I did that in my calculator and got 325,000. All right, so now I have a single equation with only one variable, x. So let's distribute the 65. I get 40x plus 422,500 minus 65x is equal to 325,000. So now let's subtract the 422,500 from both sides. And also, let's combine the two like terms. 40x minus 65x is negative 25x. And then on the right, I've got negative 97,500. Now I'm going to divide both sides by negative 25. So on the left, I get x. On the right, I get 3,900. So it looks like that's the amount she invested in the 4% account. To get the other amount, I'm going to use that equation for y. Y is equal to 6,500 minus x, so y is equal to 2,600. So I can check my answers by plugging into both of the equations. And clearly they add up to 6,500, so that's good. So the first one is she deposited $3,900 into the 4% interest account. And then the other answer is she deposited $2,600 into the 6.5% interest account. So we used a substitution method on that one. So let's look at number 15. So number 15 is a mixture problem. It says a surgeon needs 9 liters of a 3% saline solution. Saline solution means water with some salt in it. 3% saline means 3% of the solution is salt And then the other 97% is water. So she has, so to get this 9 liters of 3% solution, saline solution, she has a 1% solution and a 10% solution available. It says how many liters of the 1% solution and how many liters of the 10% solution should she mix to get the 3% solution. So once again, we're going to have some variables. We're going to have some equations, but first we have to define what the variables represent. So we look at the question, how many liters of 1% and how many liters of 10% is she going to use? So the unknowns are going to be X is the amount in liters of the 1% solution needed. Okay, then Y is going to be the amount in liters of the 10% solution needed. So we don't know how much of each she's going to use, but that's what we're asked to find out. So now we're going to set up 2 equations because we have 2 variables. There's 2 things we can figure out. So one is the amount of solution. That's the amount of liquid. And the other thing we can write down is the amount of salt, the total amount of salt in the solutions. So the amount of solution, we know she wants to end up with 9 liters, right? And she's going to mix X liters of the 1% solution together with Y liters of the 10% solution, and that those 2 amounts together have to add up to 9 liters. So we can write that down with one equation. X plus Y has to add up to 9, the amount of liquid that she's got. Now let's look at how much salt she's got. So it says that the first solution has only 1% salt. So 1% of X liters is salt. The second solution is 10% salt. So that, and there's Y liters of it, so that's 0.10 times Y. That's how much salt is in that second solution. Now, the salt from the first one plus the salt from the second one have to add up to be the amount of salt that she gets in the resulting mixture. And it says that she gets 3% of the 9 liters has to be salt, right? She's getting 9 liters of a 3% solution, means that 3% of that 9 liters is salt. So this is the salt equation. So we have the first equation is the amount of liquid she's got. The second equation is the amount of salt that she's got. All right, so we could use substitution or we could use elimination. Since I used substitution in the first, in number 14, I'm going to use elimination on this one. So the first thing I'm going to do is get rid of my decimals. It looks like I've got 2 decimal places, so I'm going to multiply everything by 100. So that equation becomes X plus 10Y equals 27. That's a much nicer looking equation to me. Now, I'm going to use elimination. So looking at the first equation, X plus Y equals 9, it looks like I can eliminate X if I just multiply that whole equation by -1. So I'll have a negative X in that equation. So let's rewrite that equation down here as negative X minus Y equals -9. Okay, so now here's my system. And all I need to do is add those 2 equations together. So X plus negative X is nothing. 10Y minus Y is 9Y, and 27 minus 9 is 18. And all we have to do now is divide both sides by 9, and we get Y equals 2. And then we take that Y and we plug it into one of the equations to get X. So I'm going to plug it into the simpler equation. x plus y equals 9, so x plus 2 equals 9, which tells us if I subtract 2 from both sides that x equals 7. So x was the 1% solution, so that means the first answer is 7 liters. And then the other answer, the 10% solution, she's got to use 2 liters of that one. 7 plus 2 equals 9 liters. And if we plug these numbers into the second equation, that also works. All right, so that's the entire, all the solutions to all 15 problems of version B of exam 1. So I'm going to post all these and get to work on the other videos for the other version, but this will get you started. All the other version, the problems are basically the same with just different numbers in most of them, but I'll make you some videos for that one too.